Welcome to the Edge Appliance demonstration. We're going to use the LECS Energy's LIMS, the Learning Integrated Manufacturing System, as we've discussed. Before we start the demonstration, what I want to remind us is that we're going to do 5 steps with the LIMS appliance. So we're going to connect to some equipment, we're going to apply some analytics, we're going to collect some data, and that data may go out in reporting, and finally we're going to control the process. So that's the steps we'd like to go through, and we're going to use a single tool called Solution Builder. And I'll refer us back to this diagram as we're going so we remember what parts of the process that we're doing. And now I'm going to switch over to Solution Builder and start the demonstration. Welcome to Solution Builder. Solution Builder is the PC-based application whose job in life it is to help you configure and analyze what's happening on the LIMS device. So on the left-hand side, there's a tree of solution engines. Remember, that's the software running in the LIMS device. And inside is a hierarchical breakdown of all of the different types of data that's inside of there. Solution engine uses Solution Builder and connects to Solution Builder via the standard MT Connect. So that allows us to use a standard to define that. You can have other tools that talk to Solution Engine as well. So here we see a list of rules. We're going to come back and build a rule in a little bit. And then we look at Modbus TCP. We see the T380 Ethernet box that's inside the LIMS device. And we can take a look at data going on inside of there. So for example, here's input 1. Input 1, we're going to graph it. And we'll see that data coming in, and that's from this temperature sensor that's laying here in my office. So that gives us data. We can also take and look at any data on the screen in the tree, drag it over, and it'll tell us conditionally, based on its type, what kind of things you might want to do. And there's, for example, red. Let's double click on that. We've got that connected to that red light up here, and we'll take a look at how to do those connections in a little bit. We see the data is a little noisy, so that's going to cause us to do things. So we see Solution Builder, a little bit of tour going on there. We're going to add quickly MT Connect .com, and that's at port 5000. We're going to connect to it. And now we add an MT Connect device that's running on the internet. But again, we can use that standard, bring it in. We also have different types of I/O. So let's take a look at how we got I/O into the system. But this shows us that we can quickly connect to different types of data and different devices if they speak that standard as well. If not, we have the I/O adapters to bring in that information and bring it into our data model. So let's take a look at bringing step 1, which is bringing in I/O. So we'll connect here to the LIMS device, and we'll look at Modbus TCP, which is running over Ethernet. So we see a T380 Ethernet device that we had added, and we can right-click on it and edit its inputs, for example, and we can set its input type for every channel, which is a set of screw terminals over here on the device. So if input 7 became a 4 to 20 milliamp sensor, for example, we'd click on that and save it, and it would save its type in the tree over there. And that would adjust all the internal connections it needs. It's called a universal input. That brings in Modbus. We can bring in OPC-UA and browse it, Ethernet IP. We could be a Modbus server as from here as well in case we're interacting with robotic systems or things. So again, we've gotten data input. We've connected to other kind of devices. We brought it in directly from some I/O, some sensors that we've wired up. And now one of the things that we see here is we're dealing with 2 problems with input 1. One is called input 1. Second problem is it's noisy. So let's fix that. So here we can create a virtual device. We can create as many virtual devices as we want, and it allows us to have semantics that we build our application around that's our semantics, not the semantics of the I/O module. We don't say screw terminal 1. That doesn't mean anything to anyone. So let's add an office temperature data item to the facility. So let's say this is office temperature, and it's a number. And again, this isn't designed for a programmer. It's on-off value, text, whatever. Those are things that most of the people out there will understand and not have to become a programmer in order to figure them out. So we've added office temperature here, but if we drag office temperature out to the screen and show it, its current value is 0. It's not connected to anything. So let's go to Modbus TCP, and if we remember, I wired that to input 1. We're going to take input 1 and just drag it into that data item and say OK. And that will now use the temperature that's coming from that device. Still noisy, though. So again, one of the things we can do is as we bring data in, we can bring it into our semantics. But the second thing we need to apply is some statistics or analytics to help clean up that data a little bit. So let's go ahead and let's remove that. Let's add this back in, and we can see that we've created some office temperature statistics. And how do we do that? Well, we just selected the statistics that we wanted to execute, and you can click on like rate of change. We could add something, power statistics that are accumulating a current value and giving kilowatt hours or something. And I just selected basic. And then I just took whatever piece of data. Now we have a new facility with an office temperature, and I just drug that into the area that is the data items we're going to execute. And those statistics are running. So no, those are things that we can deal with now. If we look at our statistics here in the tree, we'll see that that moving average is being calculated, and we can drag that into the same graph. So again, once data comes into the tree, no matter where it came from, it's fair game for you to do all of these fun things with, which includes right now just visualization. But our next step is to take the data that we've analyzed from our inputs and go to step 3, which is collecting it. Over on the palette, if you've registered or connected to a database, it appears here in the tree, and you always get the one for the LIMS box. So there's a SQLite data connector. And let's go ahead and give that a name. This is our office. This is our office data. And now what we'll do is we'll grab any data from the tree we'd like. So our moving average, our running maximum, running minimum, those are all good pieces of data that are coming from our statistics engine. And oh, by the way, let's just grab that red light and let's stick that in there as well. So there's the data we'd like to collect, and I'm just going fast. So we're going to trigger every 5 seconds. You can configure it for on change or whatever you'd like, things that you're normally used to. We've gone ahead and saved that collector, and now we'll go ahead and get it to run. So again, that data collector is not running in Builder. That data collector is running on the LIMS box. That's where the data is being stored. Now, it's cool. You have to trust me, but let's go verify. So we'll go over to our list of databases, and now we can see that Office data is in our list of data tables in the local SQLite. So let's use our database viewer. Take Office data and drag it in. And remember, a table is just like in Excel, columns and rows, which is great because you can always just take this and export it to Excel, save it, and it's a CSV file you can load into Excel. So all of the data is very approachable, whether you're just going to do some local engineering on it or not. So there's our database. Let's go in and let's change the red light since we're recording it. Let's turn it on, go back to the database viewer, and then refresh it. You can see every 5 seconds it was continuing to connect, but you can see that we now currently running, we got red. The statistics minimum, since I started this up when I started, was at 0. So that's why the minimum is setting at 0. So there we go. Now we've gotten data going out to that database, which is cool, but there's something else you need to do. Let's say that you're getting set points, recommendations back from a external data in a data table that maybe some analysis came back and gave you the answer that you might want to do. So one of the things you can do is take a database and just drag it onto the display and say, can you graph some stuff coming out of it? Running maximum and the moving average, for example. Let's go ahead and take that and graph it. Now what's going to happen is every 5 minutes, it's going to go into that table and refresh this graph. And it's going to bring the data over into our data model as well, so you can do things with it. But the most important thing is that historic data from outside sources can come, and you can evaluate that data along with your real-time data that you're working on. So that represents what we can do from bringing data in, analyzing. Now we collected it. We may be collecting it, but we're also bringing that data back in and being able to make decisions on it. And in the time I have left, what I'd like to do is to do some control and see what that's going to look like. So we're going to use the mechanism within Solution Engine called rules. So I'm just going to drag out a rule and put it here. And we're going to monitor a temperature. So this is our temp monitor system. So this is our temperature monitoring system. Now, when talking to the operator, the way in which rules are represented is there's a series of steps. And in each one of the steps, you can take an action. And actions are usually had by just dragging something out of the tree and sticking it in. So let's just talk about the scenario. We want to initialize our temperature monitoring system. Then we're just going to start checking the temperature. And if the temperature is okay, I'm just going to wait. And then when I'm done waiting, I'm just going to loop back. If the temperature was bad, I would report the temperature, report over temperature. And then once that's done, I want to reset over temperature. Okay, well, let's turn the red light off because I'm planning on using that one. Okay, so if we initialize, now we need to have some data to run against. So again, we can always create our own data. So I'm going to add a data item, which is a temperature limit, and that's a number. So it's really easy to create these data items. You can create as many as you need to. And then we can add another data item, which might be our temperature, temp for the bath that we're looking at. Or let's give it a bath. Okay, and it's a numeric as well. Again, I'm going to create my own virtual data to run the controller against, so I can just play with it and slide it around on the screen to do something with it. So I'm going to take my temperature bath and I'm going to put it up here as a slider so I can just adjust its temperature by dragging back and forth. And then I'm going to look at the temperature limit down here, which currently is setting at 0. Now, let's go ahead and build our controller. The temperature limit we're looking at initialized. The first thing we would do is probably set up our temperature limit, which might be 90. We could pull that from a database or any history that we'd like, but it's recorded here in the rule, which is great. Now we're going to do the most complicated thing we can do, which is to put in a simple decision table. So we're going to add a decision table, and in it, we're going to say if the temperature bath is greater than our temperature limit, then we're going to go to step, report over temperature. That's it. Save it. That's the most complicated thing you're going to do. So hopefully you don't feel like we programmed yet. Now, next step, if it didn't go down there, then it's just waiting. So let's give it a little time. Let's add max deck time of like 2 seconds. And now, when it's done with that, then we want to loop back. So we're going to say, go back to step, check temperature. So there's your loop, your runtime loop. And then if there's a problem, it's going to jump out here to report the over temperature. Well, the first thing I'd like to do is turn on that light. Turn it on. That's great. And then on a resetting over temperature, we want to make turn the temperature back, the red light back off. So in reporting over temperature, we're probably going to not move on until that temperature bath. We create a move on. Don't move on until the temperature bath is less than your temperature limit. Save it. So again, you just drag things into the tree, and then to reset the over temperature, we turned that off. But let's do one more thing in reporting over temperature. And I just click on the item over here and it appears on that side of the tree. I'm connected to Azure. So let's go ahead and send ourselves an email at home at 2 in the morning to let me know that there's an over temperature condition, right? So I'm going to send that to Nat@LECS Energy. And then subject is over temperature reported. And right now I'm going to temperature is over 90, right? So I can build that data up live from real data in the tree. And I'm pretty much ready to go. Now, when I'm done with resetting the over temperature, I probably ought to go back to checking the temperature again so we keep our controller going. And all I'm going to do is save that. And then we'll get it going. There we go. And now we're running. We're checking the temperature and we're waiting. We can see that our temperature limit is currently at 90 degrees. If we miss something, we can look at the history. It'll show us the steps were executed and how long they took. Now we're just sitting there waiting, so let's get that temperature cranked up. Let's bring that temperature up to 93. Okay, we reported the over temperature. We've sent it off. I've received an email, should be on its way. And then we are waiting there for that temperature to come back down in and reset that over temperature. And we are going to, at that point, we're going to bring the temperature back down in underneath 90, and we reset the over temperature, and we're back to waiting. So this is our quick controller and our rules engine that allow us to have effects and affect output on systems as we're running. So that gave us a chance to take a look at the 5 steps, which is bringing our inputs in, being able to create our own semantics or names of things, The second step was to analyze the data as we see that nice filtered moving average. Took that data, moved it out to a database, which is continuing to update, and finally have some control output so we can take that temperature and do something different with it now. So that is what is going on within Solution Builder. This is a very quick tour, but it should give you an idea of what's possible with the LIMS solution, LIMS and the solution family tools that are running on it to help you have the ability to help you start digitizing your information and understanding your process. I want to thank you for your time and appreciate you listening.